Welcome to 2019, section C, it's question C2, structural forms question. The image on the right shows a structure designed to provide shade for a seating area in a garden. Okay, so we've got this little structure. The projections of a similar structure are shown in our figure C2 below. The curved surface is produced by translating the generating parabola ABC, that parabola ABC, in a vertical position along the parabola curve, or parabolic curve DES. So here's another parabola, so it's translating that parabola along this one. In the outline in view, the dotted line shows the generating parabola ABC. B is a vertex of the parabola ABC and E is a vertex of the parabola DEF. So here's our vertex for this one and here's our vertex for this one. Draw the given elevation of the structure. So we'll start off with our elevation. So we'll do our horizontal measurements. Starting point, scale 1 is to 100, so 8 meters becomes 80 millimeters, 66 meters becomes 60 millimeters, and so on. So this is D, E, and F we haven't found yet. This is the rectangular shape that, actually I'm going to zoom in a little bit here. So this is the rectangular shape that my parabola is going to fit into. Looking at the question here, we've got 1, 2, 3, 4 divisions here for these vertical sections. So I'm going to stick to that. It's a good kind of indication, or a good idea to, if you can pick up on anything like that, use it. So that's going to be 4 divisions, so I can go 20, 40, 60. Okay, and off to the side here, what's the height is 30, can't really divide that by 4, so I'll divide this using the dividing line into equal parts method. So 1, 2, 3, 4. Join the last point back. I'll join those to our vertex E. Point. Okay, I'm just going to mirror those across, or use axial symmetry to project those across. Oh, sorry, right there. And these will all actually be equal divisions again, so just mark off my 20s because I'm going to need them in a while. So 20. there, okay, and there. That's my point F. Okay, and looking here, we've got that point at one of those divisions, which is 20 as well. So I can join that back right up, horizontal line there. Okay, so that's the projections of our elevation. Then they want us to draw the end view of the generating parabola ABC. So we want our end view over here. So maybe 10 or 15 mil. And it's 10 meters, so 100 by 80. 100, we'll mark halfway back to the position of our vertex. Okay, so that's our A, B, C. Okay, and okay, so let's divide this into 4 equal parts, and we'll divide this here into 4 equal parts also. 1, 2, 3, 4. I'll go this direction as well. 1, 2, 3, 4. That's divided in 4, and same here, the top surface, top edge. Okay, our vertical members. And join the sides then to our vertex. Use axial symmetry to find it on the opposite side. Okay, so this is all pretty basic stuff. Drawing parabolas could probably be done at junior cert level if you simplify the wording of the question. Okay, so here's our parabola. Okay, so draw my end view, so project the plan of the structure. Okay, so we need to find the plan view. Okay, let's take all these measurements with us. So we got some will be projected back, so my AB will be projected back. Yeah, AB will be projected back because this edge here will be the exact same shape of the parabola. So essentially, just so you're clear on this parabola at each one of these sections, so let's say E here, position of E, right there, okay, if I take that height, okay, this parabola, if I at that height, same height from the vertex, okay, that is an identical section to what we would see here. Okay, and say even up here, that height, if I slice down and looked in at it, I'd take the same height here, draw a line across, and that would be exactly what we get. So it's the same parabola moving along that line. So let's put in the information we can put in to begin with. So here. Find the center of it, which will be important. Center of symmetry. Okay, so here's D. F. E is technically in there. Project this down. Alright. So I'm going to start with this section here, okay, which will be in this position. Okay, so we're taking a section through our shape at that position, and that will find us an ellipse, okay, of this height in this position, sorry, that height, stepped off. So that would be approximately the ellipse that we're going to get. But this doesn't go all the way down to the ground, so we're only going to take that little section of it and step it off and draw a line across. And that will find us a width that we'll be able to bring down and find those points there and there. Okay, so let's start with that first distance. Stepped off. Okay, so that is essentially the parabola that we would see in this position if we chopped it. Let's bring that down. Okay, and I'll repeat the same thing now with each one of these sections. So, next section. If you wanted to, you could just take this distance on your compass and project it down. So all the one, whichever way it works for you. Okay, so that's one bit, and then we're on to E, another section. So this can be a bit repetitive. From B, find that. Just to show you, I'll do it that way here. So that distance out to my parabola, find the position of the section through, and step it off from the axis. Okay. just repeat that again. So that height actually is going to be the same. Great. So that height and that height are the same, and I've projected them to there, so I can actually project them a little bit further forward. And bring that down. It's great, this will save me a little bit of time. Okay, and we've got another shared height. No, that wasn't, because we took that height there instead of the full height. I'll project this down anyway. I'll need it later, those cut sections. So, height of the section. That. And the width of it. So I'll just use the quicker method here again. That distance. An arc, and then the last bit. Height, get that, find that distance, get the width, step it off there, and there. Okay, so now I'll draw a freehand of my shape. So nice gradual curve looking to the point you're going to all the time. Something not quite right with that. See, let's go a lot further out. So that mistake there. Section there. See what I did? Forgot to project this at 45 degrees and down, so that should be going to here. Okay, here's some pen so you can rub that out in your own time. You shouldn't have made that mistake anyway. If you follow the steps, it's just a small error from me. Okay, so like I said, for that bit out, I just projected down the wrong point there. Next thing in our question, double check they've asked for the plan, and we've drawn everything that is included in the plan. Right, the projections of an overhead telephone line PQ are shown. So we got PQ overhead telephone line. Draw the elevation and plan of PQ and determine the vertical distance from point R here, okay, which is in line with that section on the surface. Okay, so we don't have R. R is going to be somewhere along this section because it's along there. So we need to find the distance from PQ down to R. Let's first off draw line PQ. Okay, it's up 30 there. PQ. And down Q and P. Okay, so the distance from there to there, they're asking us to find where it is on that. So if I find the distance of that, I'm taking the section through, and finally the height will step down. Perfect. Okay, so this width, I'm going to bring it back. That's the right this direction, back up to here. And that is going to determine this height from it. Okay, that height from there to there. Because essentially what we've got is another section through, creating this small little parabola. Zoom in again just so we can see what's going on there. So I've basically taken a section there at that point, brought it back, and that is giving us that. So that height h for this parabola is the height down that we're coming, because it's a identical parabola. So yeah, so that height, get that height h. It's a little bit too short, I'll have to do this by eye. So mine is just exactly through 4 millimeters, so I'm going to measure 4 millimeters. Okay, my compass lead is a little short here, should be just fine. Down from there, 4. So that is the position of R. That's a point on the surface, isn't it? Determine the vertical distance from point R on the surface. So let's say that's R, and that is point R there. And they're asking us to determine the distance, so the vertical height there from there to there. We can measure that height then. Okay, so in my case it is 63 millimeters, which is 6.3 meters if we're using our scale. Okay, so that's our solution there. Zoom out a little bit again so you can see it all. So that's our solution to the 2019 section C structural forms question.